Hi guys. So this topic is quite nerdy, so I'll share a lot of code. I don't have a lot of funny pictures. Sorry for that, but this is what we have. In case if you want to look at code closer on your laptop, you can just go to this link, GitHub.io. So this presentation is right here on my website, so you can get the code. So actually it's text, not an images. All example of code is our text, so you can copy, paste, and play with it. So who I am? I'm developer in Debitur project. I work in the office of Cyclum, so that's why I'm in two companies, because Cyclum is our staffing company. And we'll talk about errors in Node.js streams. And yeah, before you start, in the end there will be a question session, and for the best question I'll give to you a ticket to JS Framework Days that will be on 1st of December in Kiev. So be active and get your reward. So about me, I'm 7 years in development, and 5 years of them I'm in JavaScript and in Node.js. I'm in charge at the challenge. I was using a lot of technology in my life, even Go, React, Ruby, Backbone, PHP, even those that are, some of them are technologies, some languages, but anyway, that's something I used in my development career. And I have my own projects like Tankly and Humans with Zombies KVA, and maybe Tankly we can play after this talk. It's a quite fun game that everyone can participate from your smartphones. So let's talk about streams. So all of you are using Node.js, right? A lot of you, okay. And do you know what are Node.js streams? Okay, a bit less of you, and that's okay, because I thought that not all of you know about streams, but you're here to learn something. So I'll try to explain what are just streams. So this is what says documentation on Node.js org. So it's kind of some sort of abstract interface that helps you to deal with data and implement stream interface. Some random shit that, personally for me, I can't understand what are streams just from this documentation. So I'll try to explain you from real code. Whoops, why it's jumping? So let's say we have Express application. Most of you are using Express, I think, that are using Node.js. So for instance, we have a task to send file from backend to our API clients. So what we can do, we can just read file synchronously or asynchronously, it doesn't matter with modulfs, and just send the content to response. And all the content of the file will be stored in this variable content. And actually, if file will be big, really big, there is a big chance that our app will crash, because we'll be out of memory and we'll need to go to our boss and say, hey, we need larger servers and so on, and your development costs will increase and so on. And actually, your Node.js application will send file just after we'll read entire file. So that's slow, it's okay. In some languages, platforms, it's the only way how to send your file to API customers, but Node has something better for that. It's called streams, obviously. But let's take a look at another example. For instance, MongoDB. There's a small simple where we get in just all collections. We need to initially collection find returns on the cursor. We can convert them to array. We can get all these documents in one variable here, and after we can send them with res.json. So in this case, we also start and send in our data right after we retrieve all the data from database. It's also slow, and it also can take a lot of memory if you have a big collection of data. Getting all the data into your RAM, it's quite expensive. Node has something better for that. And this is an example with streams, so how we can send this file with streams in Node.js. So actually, streams, how we can get stream from file. So we have a special syntax, special method from FS module to get this stream, and from this stream we can get some events. One of them is data, one of them is and there are also some other events we can get from from this object. So what is good here, that we can get only one chunk of data, one small piece of data, and immediately write it to our response, because response in Node, in Express, is also a stream, so you can write only chunk of data without taking care of all the rest of the file. And so you'll receive chunk of data, send the chunk of data. So nothing is stored in memory, everything is fast. You start and deliver your file right after you start reading it. And in the end, you just need to end your stream. So this is like a benefit from streams. So just to avoid this manual handling of events like on data on end, there is a good function of stream called pipe. So actually you can say that I don't care all about these events, I just want to get some readable stream here, and I have writable stream here. I just want to get from one stream to another stream, and I don't care about events. So this is what pipes do. But also it has some internal optimizations. For instance, if backend can't send all data right away, you can say to read stream, hey, stop for a bit. So there are some events called drain and pause. So readable stream can stop for a while reading data, and until response will finish writing his data to API client, and after we can continue sending some data. So let's say how we can send a lot of data from database to response pretty fast. So actually Mongo client can also give us a stream. So initially collection find returns us a cursor, and cursor has a method called stream. So you can also stream all your data from MongoDB to response. But before just writing to response, we need to stringify it, because from stream we are getting JavaScript objects, and you need to stringify them. And JSON stringify, it's just an instance of transform streams that transforms JavaScript object to strings that can be writable to response. And as far as you can see, you can pipe a lot of streams together, so you can implement a lot of transformations in the middle. For instance, you can modify your data on fly and so on, so you don't need to get entire bulk of your objects and do it with loops or something. You can do everything in stream, but you can read about transform objects in documentation. I'm going to talk about some other interesting things of Node.js streams. So how Node.js streams are fast? So this is a screenshot from our main application. So we are using our instance as a router. So we are proxying all requests from API to some other microservices. And we're not storing all the requests in this instance. We are just streaming everything. So so we can see it consumes only, I don't know, 65 megabytes of memory. So it's absolutely not memory consuming. That's why it's great. So finally, we can start talking about error handling. So how actually we can get this error in this infinite process? How we can get it? So what we know from documentation of Node.js streams is we have some kind of error event called error, and we can try to console it or something. So we still have this pipe of streams. At some point we can get at least we can log this error here. So just to simulate the error in stream, I've put this fake operator here in find, so Mongo can't handle it, obviously, and it should fail somehow. At least we should get error, I think, here. And any ideas what we'll get in response? I'll show you. Actually, we'll get empty array. So if Mongo fails, as a response, we'll get response to 100, and actually we'll get an empty array with no clue. So our API client, our API users didn't know that error actually happened. So we can log it internally, but we can't send that to our customer like an error. actually we can try to do it, and I'll show you how. So yeah, we got this error in console. Yeah, and it's pretty nice. I think we should try to do something with that. I don't know, maybe try to send 503 or something, because that's error in backend, right? So what we can try to do, we can try to destroy stream. So it's also one method of streams. So let's try. What we'll do. So actually, in our client, we'll just get failed request. We'll get empty response, but at least it will be not 200 and with empty array. Our single page application can say can get information. Okay, something went wrong, and our application will not modify, for instance, our collection with empty list, right? So and we can show something to user that something went wrong, and it's not the problem that you have no more data in your collection, right? It's actually some internal problem. So this is a possible way to solve the problem. So because when we are doing streaming, we are sending headers immediately. So it's quite hard to, sometimes it's impossible to modify the HTTP code and message and so on. But at least it's not 200, and well, it's better. What we can do, actually we can try to send this new status and some JSON. Yeah, maybe this stream failed before started sending some data, right? So we can try to do that. So actually, it works for even if stream started sending some data. We still can get send 500 with some JSON. That's even better for single page applications, right? So we know what's the problem and not just error closed. But not so fast, because actually our app crashed because for some reasons to response stream was sent some another chunk of data after we sent JSON. So what happened? We sent 500 in JSON, and stream was continuing to send in some information to our response, and that's we've got uncaught exception and actually just unhandled error. Okay, we have unhandled error events. Let's handle a few more events in streams, right? Let's log this error at least. So this piece of code just added. Let's try to see what will happen. In this case, we can see that after we sent 500, our stream was trying to send data a few more times. So how that happened? Our Mongo stream, readable stream, so it didn't destroy it. It didn't stop working. So it was continuing to send something. I don't know even what, but it was trying to send something after we sent a response to our client. So that's also not good. So that's why we need to deal with all kinds of events, all kinds of situations in our streams. So at least we should listen to these 5 events. So they can be completed with error, closed, exited, ended, and aborted. Some of them are methods from streams .1, from old implementation of Node.js streams. Some of them are from new implementation of Node.js streams. And we need to listen to all of them. And so you can imagine how big this code can be. So right here, we just listen to error message of one stream, error message from writable stream, response. And in the middle, we also have error here. And actually, at this stream, we can also get an error. And we also need to listen to all the errors we are using in our pipeline. That's crazy. Thanks, Matthias. I wanted to say God, but Matthias, we have a module called add-of-stream that can handle all these events and even more. And it can provide you one simple callback to all your streams. So when it's completed or when it's failed, anyway, you'll get one callback and with optional error object inside of that. So inside of end of stream, it listens to all kinds of events and trying to provide only one callback, one exit point to from all this madness. So what's here? Okay, so our stream was trying to send us some data, right? And well, it's not okay for MongoJS stream to continue working. Actually, as a readable stream, we can have a lot of different other streams that continue to work after this error, after we get this bad situation. So what we should do, we should actually manually destroy this DB stream, and also we should destroy response stream. It should not, after we send some data or interrupted our request, we should just destroy it and do not try to send anything else. Yeah, here I put this send status 500 in try catch, just because we don't know if we send our data, if our request is completed or not. Actually, if we can set headers again or we cannot. Thanks, Matthias. We have yet another module, pump, so that can do some stuff for us. So what we can do, so pump is a model just to deal with all those streams. It's a replacement for pipe. So with pipe, we need to get information about all these errors, completions, and so on. But with pump, we can just provide all the chain of streams by comma, and internally, inside of it, it uses pipe, but it also uses end of stream model just to verify that all streams finished with error or with result. Doesn't matter, and it also can provide you one simple callback when streams actually ended, and it can also give you an error. So only in one place you can get this error, so you can log it, for instance, for your initial needs, maybe to your log entries or some other log service stuff. So after you can take a look and figure out what's going on. But what also it does, pump destroys all the streams that are in chain. So whenever a stream is getting destroyed or errored or something, it destroys all other streams for you. So you don't need to care about thousands of events and thousands of streams you have in your pipeline of streams. Yeah, that's it. And one more thing about good usage for streams. It's proxying streams. Actually request, I'm not sure if you know, but request can be used as a duplex stream, both for getting some data as a stream, to get some data from stream, and to write some data into stream. So it's, of course, you can use it with as a callback, with callbacks when you get all the data. But when you're writing a pull, when you're writing a proxy server, for instance, if you want to proxy all requests from your main application to your microservices, well, it's better to use with stream because they are fast. And I saw, you remember this picture of memory consumption of our app, and it takes only, I know, 60 megabytes to handle all of that. So request can be used as a duplex stream. It can read some data from request from some other request from some other stream. So in this pipeline you can see that we are proxying all requests to this stream. It can do some other internal stream, and after you can write result to response. Just to make it more clear, I have this picture how this will work. So we've got requests from our API users. We can create requests as a duplex stream. It will make some requests to some other service, return some data, and after we can put it back to our initial response. And everything with streams, everything with zero memory consumption, super fast, and so on. But damn it. What we can do here, so we can see that we just have this streams piped together, and well, what we can do if actually stream failed, for our API users, it's better to provide successful request rather than failed request. So what if our other service returned 503 just because of a networking issue or something, and maybe this service can return a successful response after a while, after 1 second, let's say. So when we get an error from internal server, we can get some error messages like connection reset or not found or timeout or some other stuff, or connection refused, for instance, if there is a network problem. And potentially we can play a lot with these events and retry to do this request as a stream. So we wrote a new model called request retry stream. So I'm not going to dive deep into this event madness of streams inside of it, but what it does, it checks the initial code from internal service and try to make one more request and see if it works and pipe it back to our API customers. So you can check it here. So how it looks, how to use it. So you can just replace normal request with request retry stream. So it uses the same API as normal request, and you can use it in a stream here. So no extra configuration. So you just say how many attempts you want to do and how many timeouts. So with normal request, when you have request with callback, you can make recursive functions that will retry some to get some data and send it back. But with streams, it's more tricky. It requires some stream magic. You can take a look at source code of this function later. So in case of get, it's use if you have method get, it's good to use this request retry stream and try to get this data. Why you should use normal request if your method is not get? So when you're doing a post request or put request, you can change the state of your documents, right? So inside of these retries, actually requests can still continue for some time. Maybe you send some data and some internal service is just proceeding with this request for a long time, but you've got timeouts from here and you need to cut down your requests and retry again and so on. So potentially retrying requests can just do one thing multiple times, and this can harm your data. And even more, maybe it can cost you money. So for all others than get, you should use normal request. So you'll know that it's better not to retry post and put requests at all. Yeah, I think it's basically it. So what to read? So first of all, Node.js documentation about streams. Check out GitHub of Matthias Macintosh. He wrote a lot of models to deal with streams correctly, with all this error handling and so on. So there is our package. So you can check the streaming section of request package, so you can know that request can get some data and send some data as a stream. And request retry stream, obviously, and all these models, end of stream and pump, that can help you to deal with streams correctly as well. These slides are available on GitHub, eagle-eye GitHub.io. Thanks for attention. Any questions? Yeah.
Could you please explain me one thing? Is there a way to use the request proxifying not with request library, but with request promise library, since we use request promise and it's quite great. Is there a way, or dirty hack maybe, to use them together, or it's just a request library?
From promises, you can get the end result. You can so you'll store all your results and body requests in memory, and it will be just slower. Of course, you can do it, but you'll not get benefits from streams.
Sorry, my question probably is not good. It's kind of nitpicking. Can you get back to the prior slide with the code? I think, yeah. I'm not sure I get it, especially else branch. So am I right that proxy request is not initialized in this branch? And thus, how pump work in such scenario?
So in else, it's good to use the same block as here, but instead of RRC get, we can use request.existing method here. So we'll just replace request retry with normal request in this else. How pump will work? Pump just listens to destroy events and errors here.
Sorry, I'm not sure. So, can you please elaborate? So, I will create still proxy request object.
Yes, that will be used by
which call
request.
From request? I'm not sure I get it. Would it be called from RRS or from an original request? I just don't understand which code should I put in that else.
Which code? Okay, we can just do some live coding for you. I can just write what it should be there. So here, what we should have, it should be proxy request equals normal request dot.
I mean, you mean request library? Yeah, sorry.
Yeah, just request library normal.
Yeah.
And
I thought that it was request like variable rec.
yeah, sorry, yeah. Good point. Yeah, I was talking about request library.
Обычно, когда предлагают юзать стримы, обычно предлагают такие использовать реквесты типа отослать request, либо download файлов. Но, в принципе, чаще всего мы юзаем, я не знаю, не всегда Mongo, допустим. Как же, допустим, если мы будем юзать, там, я не знаю, MySQL или Postgres, как мы там будем юзать стримы? Либо нужна нам валидация реквестов. Как уже жить с этим?
Okay, there is a question about validation, how we can validate the streams and data inside of streams. So at this middle point, we can have a proxy stream. Instead of proxy stream or before the proxy stream or whenever, we can have a transform stream that will reiterate through all your objects one by one. And in case of some problems, it can give you some error and it can, for instance, filter it from further push into response stream or writable stream after. So you can validate all your data on fly as well. Regarding MySQL and so on, so it's just a matter of implementing driver for that. In theory, so normally you're connecting to MySQL with TCP requests as far as I get, right? And TCP request is also a stream. So it's just a matter of writing driver. So I haven't checked the driver of MySQL as well, but it should be absolutely possible to use it.
Ну да, потому в Mongo это удобно, потому что там без курсоры. А вот Muscle и этот там уже немного посложнее. Ясненько, спасибо.
Okay, thank you, Andrii, for your beautiful speech.
Okay, so I need to find the best question. I like the first question from Guy. Just come to me and I'll get your email and give you a ticket because I like your question. Thank you, guys.